All right. Hey everyone. I want to put together a quick instructional video on a tool that I recently designed, architected, uh, that has to do with creating libraries for the DipTrace tool for PCBs. So I've never really used DipTrace in the past, but lately I've been kind of enjoying the simplicity of DipTrace compared to a lot of the complexity in the other tools. But one of the challenges I found with it, I'm the kind of person who really likes an atomic library where every part that I pull as I'm doing the schematic design already has a manufacturer's part number and a footprint. I know exactly what it's going to be rather than just putting generic passives on the schematic and deciding package and part number later. And DipTrace had, by default, it was a little bit of a challenge to kind of figure out how to put that kind of library together. So I came up with a tool that uses a GUI where you can start with a template library and with a single component in it, and then using a CSV with all of your part data for a whole family, you can put together um, a full library, a single library with an entire family. So what I'm going to do here, I'm going to show off the tool that I created and uh, sort of run through a full process of creating a family of components, capacitors, as an example. So let me pull this down here. So I figure what we'll do is we'll make a family of tantalum capacitors. I've already chosen a subset of the T491 family. And I'm going to do the entire process start to finish right here live. And so what we're going to do to begin with, we need a few things. We need the footprints created by hand, just for however many footprints that are going to be unique. We need the schematic symbol created for a single, or actually really two, template parts. And we need the data downloaded. So I'm going to start by downloading the data here. So I'm going to use DigiKey to download the data. So I'm going to go ahead and download this CSV. And it's a subset of 41 capacitors. All right, so I've got the CSV here. Go ahead and open this guy up, and we're going to do a little bit of cleanup on the CSV first, just because there's some stuff we do need, some stuff we don't need. So for example, I don't need the image. I don't need the DigiKey part number. Let's see. I don't need the supplier because it's different. I will keep the description. And by the way, this tool that that I'm using, it will attach all the parameters from the CSV as extra fields. So if you have the idea of wanting to know what your component's tolerance or voltage rating or any of that stuff is, it'll be right there for you. Go ahead and delete those. I'll keep the series in there. Product status, it could go out of date anyway. Tolerance, voltage, I don't need the type. ESR will keep. Lifetime mounting type, well, it's fairly obvious. Package height will keep. Spacing we'll delete. We'll keep the manufacturer's size code. We'll delete this one, and we don't need the DigiKey URL either. And we're going to make just a couple more modifications. So all of these are rated AEC-Q 200, so we'll go ahead and change that. I don't need this one, that's redundant. That's also redundant. And I'm going to make some quick changes to the temperature. Let's see, didn't get that one. And this is just the format that I'm using for my library. Of course, whatever you're doing, you might want to modify. I'm going to make another quick change to the capacitance. This is going to be a value column. And for this one, here's what I'm going to do. Phew, we're getting there. Get rid of the space, and then one last thing. I'm going to use only letters, not the Greek letters in my library. Okay, that's the format I want for the value. Of course, however you want to do it is up to you. Everything is microfarad, so we don't need to make any other changes to that column. Okay, so our CSV is good to go. Okay, so now we need to do make some patterns here. So what we'll do, we'll add new pattern using the 7351 pattern generator in here, which is absolutely phenomenal. And we're going to do two different footprints here. So I've got the data sheet. Okay. And so what we're going to do cap, and this is polarized cap. Okay, perfect. And what we're going to do is I'm going to use, all right, so A is the thickness here. And so on ours, we're going to do A and B. And so the thickness is under H, so we'll do A first. 1.6 plus or minus 0.2. So 1.6, 0.2, okay. And then the B, that's the lead width, so that's going to be E on here. L, E, ref, 1.3. Okay, so that's 1.3, 1.3, 1.3. All right, and then B1 will be the same. And D, that is overall length, including the terminals. So that's going to be L on this device. And so for L, we're looking at 3.2 plus or minus 0.2. And D1 is going to be the body length itself, not counting the terminals. Is that even listed? I don't see that listed here. So we'll just give L the exact same, the 3.2. Okay, and then E. E is going to be the width of the device, so W, 1.6 plus or minus 0.2. Okay, and L here, terminal length underneath, that's going to be some quick math, L minus A divided by 2. So what we'll do for that one, 3.2 minus 1.2, and that gives us 2 divided by 2. That'll be 1, and I'm not going to bother with the tolerance for that one. So that'll be 1 and 1, and we'll do 1 and 1. Okay, awesome. And what did I miss here? This is case code A, manufacturer, Kemet. Okay. I need to adjust this. Ooh, 0.07, that's what I prefer. Okay, there we go. We got it calculated. Okay, now we could do multiple density levels, which I really love doing. Let's go ahead and make sure that I've got everything in here. All right. Silk, courtyard, terminal options, design rules, 3D. I'm going to include the polarity marker. The only other thing I'm going to do is I'm going to adjust this to be a classic sort of yellowish orange color for this tantalum cap. So let's see, we're Not too great with colors. Let's probably be about right. A little more orange, a little more yellow. We'll do that one right there. Okay, we'll leave everything else the same. Okay, recalculate. Uh-oh, lost my mouse. We're gonna have to do this with the keyboard for a moment. All right. Well, everything USB is gone. All right, there we go. We're back. Okay, so we've got Kemet A, and A, 3 density levels. Okay, we're gonna do that real quick again. We're gonna new pattern 7351, and we're gonna do this for B. We're gonna do molded. All right, now for the molded, where did we go here? Go back over. We're gonna do B. Oops. All right, so the length is 3.5 instead of 3.2. Okay, the width instead of 1.6, we're at 2.8. It's this guy. All right, the height instead of 1.6, we're at 1.9. Okay. And the terminal width is 2.2. That's going to be our B. Oops. Okay, total body length, D, that's going to be our L. We already got that one. Okay, we changed. We get D1. We're going to put that one also at 3.5. And we got E, and last one here will be, let's see, L minus A, so 3.5 minus 1.9. Divide that by 2, and we're at 0.8 right here. Oops. Okay, there we go. We've got that. Now we're going to go ahead and use code B from Kemet here. And we'll make sure that our terminal solder mask. Okay, we'll recalculate that, add all density levels. There we go. Okay, so now our library has these components in it. So we have to go back to our CSV real quick, and we do need to do a footprint. All we have to do here, copy this. Actually, you know what? I don't even need to copy it. Footprint, and what we'll do. Okay, so I'm going to use the nominal for all these, and I've got the others in the library just in case. Okay, so Kemet A N. No, do this here. Okay, there we go. Now we can programmatically generate that. All right, so we've got our CSV with the footprint. We've got our footprints created. Okay, we'll make sure we save this library. Okay, now we need to make a template library for our schematic symbol here. Okay, so what I'll do, I'll go ahead and create a new library in here. We're going to call it passive cap SMD, and I will go ahead and call this T491. Okay, there we go. Created that. So now let's create a quick symbol. We'll use a polarized. Let's see which symbol we like. Oh, of course we like this one right here. All right, now I'm a little particular with my library. I like origin of point of pin 1, pin plus here. To be there, and then our total width is 0.4. I'm going to go ahead and tweak that. Make it just a touch smaller. I like this default symbol. It looks good, but make sure we're on a 100 mil grid for later. Okay, so we'll go ahead and call that good. Now, here's the thing. We're going to need 2 caps in this library. One of them, we're going to need to attach the A footprint. Oh, whoops. And we'll go with, that's going to be 1 and that's going to be 2. And by the way, let's just double check our document here. Let's see, how shall we do this? You know what? That's right. This is polarized cap like this. We're going to actually do something different. Oh, if I can get back to my window. Where'd it go? I know it's there. There it is. Okay. Okay, here's what we're going to do. We're actually going to modify some pins here. Name here is plus. We're going to call that A for anode. Okay, it does not need to show anything. We're going to call this one K for cathode. Okay, that's fine. And then what we'll do, let's go ahead and save this library while we're at it. We'll make a new folder in here. Passive cap SMD. We'll save it as a XML in a second. Let's go ahead and get into our pattern editor again briefly. And what we'll do, let's see. All right, so I'm a little new at DipTrace. We'll make sure we can set these pins as A and K. And you know what? While we're here, let's look at our 3D model. Okay, there we go. Beautiful. Yeah, a little funky, but it'll certainly work for a 3D model. That's fine. Okay, and then this guy, this is K. All right, and we're going to go ahead and make that modification to all of these footprints. Instead of 1, we're going to go A. Instead of 2, we're going to go K. A. K. Okay. All right, now we'll save. Go ahead and save that. All those have been modified. Okay, now let's attach our pattern. And so for this one, oh, shucks, and K. Name and number, K. Name and number, K. Okay, attach our pattern. So now it's going to auto match here because they're identical pin. Okay, so we've got this attached to A, and what we'll do, we'll go ahead and duplicate this, and for this one, we're going to attach it to B, nominal. Okay, all right, we'll go ahead and save that. All right, now we're going to save this library not as a binary file, but actually as a XML. That's key. Okay, there's the library. Let's go ahead and close the window here, and now what we can do is we can open up this Python script. Okay, make sure that this is fully visible here. Great. And let's go ahead and open up the library. So this is a Qt or a TK GUI. Oh, where did I save my CSV? Maybe I didn't save it. Save as. We'll stick it in the save. There it is. Okay, and this is going to create an output XML file. All right, so all we have to do here, we're going to pick one of the components to be our template for the schematic symbol. The fields down here, we need to make sure that the fields are mapping correctly. So the manufacturer part number is the name, the DipTrace name. Oh, we forgot one thing. All right, so here's what we're going to do. We're going to go back into the component editor just in case I'm going to run these as Spice. In a Spice simulation, I'll go ahead and edit the Spice model for both of these. These will both be capacitors. And then the value, now here's what I'm going to do. I'm actually going to pick a value for both of these. And even though it's not really necessary, but it's just so that the tool can pick up on it. Okay, so this one, capacitor 1U. And then this one, capacitor 10U. Oh, this is interesting. That pin should be A, and that pin should be K. I wonder if I made that mistake before. Okay, that pin, A and K. Let's double check here. A to A, K to K. Ah, that was almost a mistake. A to A, K to K. Okay. Save it. Close it. Reload our files. Okay, now we're good. We've got the manufacturer part number for the name, value for value, manufacturer, data sheet. That's our link there. Description, height. We'll put that as height seated max. We've got temp min, temp max, and footprint. Okay, now every one of those columns in the CSV that's not listed here is going to be, I'll bring this up so you can see it. Every other column is going to just be added as a parameter. So we'll click validate, validation passed. Okay, we're going to build the library and exit. Okay, now we'll open up the component editor, and hopefully this is where the magic's going to happen. Bring this up here. Now let's open up. I'll do a little library setup. Oh, froze here. If anyone watches this, DipTrace would love to get some official Linux support. All right, we'll go ahead and now we'll do some library setup. Go ahead and move from there. I'll add that library there. Okay. Oh, I added the wrong one. Delete, delete, And we got to add our generated library there. Okay, there we go. Okay, now here's the magic. What you'll notice here is we've got all of those 41 capacitors now, all included in our library, correct footprints mapped. And if I was going to go bring those into the schematic, we can see all the correct properties are listed right here. And yeah, it took me a few minutes. We're at about 26 minutes of doing this from scratch, but now I'll never have to make another one of these symbols or footprints again, no matter which cap from this family I want to use. So thanks for spending the time to check this out.